Now, in this chapter, kids, we will discuss your chemical nomenclatures. A nomenclature, kids, is a collection of rules for naming things and is important in science and in many other situations. Nomenclature, again, is a collection of rules for naming things and is important in science and in many other situations. This module describes an approach that is used to name simple ionic and molecular compounds such as NaCl, CaCO3, and N2O4. The simplest of these are binary compounds. Kapag kita binary compounds, these are these are compounds that contains two elements. Again, binary compound siya, dual lang siya ka elements. But we'll also consider how to name ionic compounds containing polyatomic ions and one specific and very important class of compound known as acids. Subsequent chapters in this text will focus on these compounds in great detail. We will limit our attention here to inorganic compounds that are composed principally of elements other than carbon. And then follow the nomenclature guidelines proposed by our IUPAC, ang kapangalan na sang ato na elements. The rules for organic compounds in which carbon is the principal element will be treated in a later chapter on your organic chemistry. First and foremost, pangatagpangan sa ionic compounds. To name an inorganic compound, you need to consider the answers to several questions. First, is the compound ionic or molecular? Patabalan if ionic or molecular. If the compound is ionic, does the metal form ions of only one type? Kaya again, fixed na charge siya. Ano ganun charge dapat sa ating ionic compounds? It must be equal. Or more than one type, meaning may variable charge siya. Are the ions monatomic or polyatomic? If the compound is molecular, does it contain hydrogen? If so, does it also contain oxygen? From the answer we derived, we place the compound in an appropriate category and then name it accordingly. We'll begin with the nomenclature rules for ionic compounds. So, starting with our ionic compounds, kids, we will discuss the compounds containing only monatomic ions. The name of binary compounds containing only monatomic ions consists of the name of the cation, followed by the name of the anion. Some examples are given in table 2.7.2. Tandaan nyo lang, kids, take important note, the name of the non-metallic element with its ending is replaced by the suffix of IDE. IDE. So, instead of chlorine, naging chloride. Instead of bromine, nag-bromide. Calcium iodine, nag-iodide. Dapat, kids, tandaan nyo, permi una, when naming your monatomic ions, una, permi si cation kaysa kay anion. Magamba kita cation, again, it is the positively charged atom. Magamba kita anion, it is the negatively charged ion. So, sa Na hindi, siya ni si positive. And si chlorine nandaton, siya ni si negative. Kasi dapat permigit una si cation kaysa kay anion. Alangan mag-chlorine, sodium, di ba? Hindi pwede. Kaya baliskat pa si bromine kag si potassium, dapat permigit una in our rules si cation kaysa kay anion. So this is an example of our monatomic ions. And ang iyang nga punta, kids, ang aton nga anion, gina-replacean naton sang IDE. Malangit na siya, kids. Kung butangan ta magnesium kag duha ka oxygen. Magnesium and oxygen, kids. Una ko si cation, next ko si anion. How do I read this? I read this as magnesium oxide. And that is when you're naming monatomic ions. O compounds containing polyatomic ions naman kita. Compounds containing polyatomic ions, compounds are named similar to those containing monatomic ions, except there is no need to change to an IDE ending since the suffix is already present in the name of the anion. Meaning, hindi ka na mag-change to IDE sa iyang punta kung magambay kita polyatomic ions. Because, magambay kita polyatomic ions, kids, clone siyang element, Na, H, or more. Kaya polyatomic ion siya. Ngayon ang punta ya, kids, is mayroon na siyang daan na kabutang. Because the suffix is already present in the name of the anion. Cyanide compounds in your cabinets. Every day you encounter and use a large number of ionic compounds. Some of these compounds, where they are found and what they are used for, are listed in Table 2.7.3. Look at the label of ingredients list on the various products that you use. In the next video, see if you run into any of those in this table or find any other ionic compounds that you could now name or write in a formula. Kasi sa table salt natin is just sodium chloride. Ang ato na toothpaste is your sodium fluoride and na toothbrush natin. Sodium bicarbonate is just baking soda. Sodium carbonate natin is washing soda. Huwag makita nyo gid kids, testingan nyo, if pwede nyo masulat. Or makabala na kung magsulat sa ionic compounds na. Kaya again, tandaan yung paano ito siya ma-identify again kids kung ionic compound siya. If it is neutral, equal ang niya proton and iyang electron. Next, you have compounds containing a metal ion with a variable change. Most of the transition metals can form two or more cations with different charges. Compounds of these metals with nonmetals are named with the same method as compounds in the first category, except the charge of the metal ion specified with the Roman numeral in the parentheses after the name of the metal. The charge of the ion metal is determined from the formula of the compound and the charge of the anion. For example, consider your binary ionic compounds of iron and chlorine. Iron typically exhibits a charge of either +2 or 3+, and the two corresponding compound formulas are FeCl2. And the FeCl3, the simplest name of your iron chloride, ang yang pag-pronounce. Well, in this case, that would be ambiguous as it does not distinguish between these two compounds. Again, kay ang isa ka FeCl naton has a subscript of 2. And ang isa ka FeCl naton has a subscript of 3. Ay may subscript siya nga 2 kag 3. Alangan basahan nyo lang siya nga iron chloride. Well, in this case, that would be ambiguous, correct? As it does not distinguish between these two compounds. In cases like this, the charge of the metal ion is included in the Roman numeral in parentheses immediately following the metal name. These two compounds are then unambiguously named iron 2 chloride and iron 3 chloride respectively para hindi lang ito magambal iron chloride. Meaning, sa ending niya, di mabasa ito sa subscript. Butangan ta siya sa Roman numeral, magpapangalan kita sa aton nga chloride. Magpapangalan kita again sa aton nga chloride, butangan ta siya sa aton nga Roman numeral. So these are an example in your table 2.74 of those with the subscript. So iron 3 chloride, mercury 1 chloride, kaya may ara lang siya sang isa ka oxygen, HgO, mercury 2 oxide, so on and so forth. And that is how you name the compounds containing a metal ion with a variable change in their subscript. So out-of-date nomenclature use the suffixes of IC or OUS to designate metals with higher and lower charges respectively. But now, sa aton nga modern times, ginagamit na lang natin is your Roman numerals. Ay, isang una, ang aton FeCl3 is called your ferric chloride, and iron 2 chloride, or FeCl2 is known as your ferrous chloride. Though this naming is conventionally abandoned by the scientific community, meaning sa chemistry and other forms of sciences, biology and such, wala na yung ginagamit ang mga ferrous chloride, but it remains in use in subsegments of industry. For example, the food industry, ginagamit pa. For example, you may use the stannous chloride on a tube of toothpaste. This represents the formula of SNF2, which is more properly named tin 2 chloride. And that is the explanation. Next, we have the molecular and covalent compounds. Next, you have your molecular covalent compounds. The bonding characteristics of inorganic molecular compounds are different from ionic compounds, and they are named using a different system as well. The charges of cations and anions dictate their ratios in ionic compounds. So, specifying the names of the ions provides sufficient information to determine the chemical forms. However, because covalent bonding allows for information to determine significant variation in the combination ratios of the atoms in a molecule, the names for molecular compounds must explicitly identify these ratios. And why is this? So, dun duwa nyo kaginakid sa ngayon, yung compounds natin, di ba, equals to ang ilayang protons and electrons. Si diri kids, kay nag-share sila sa protons, kagila electrons, ang positive nila, pag ang ilang nga negative, ginashare nila kids nga duwa. Therefore, these are now your covalent bonding of your molecular compounds. So, paano naman natin sila pangailangan nun? Compounds composed of two elements. And two non-metallic elements form a molecular compound. Several combination ratios are often possible. For example, carbon and oxygen can form a compound CO and CO2. Since these are different substances with different properties, they cannot both have the same name of carbon oxide. To deal with this situation, use a naming method that is somewhat similar for those that is used in the compound, but with added prefixes to specify the number of atoms of each element. The name of more metallic elements is the first, followed by the name of the non-metallic una si metallic element. Next is the non-metallic element, and which is the ending is changed to IDE. The number of atoms of each element are designated with the Greek prefixes below. And kids, ang iya prefix is hexa, F6, hepta, F7, octa, F8, 9, nona, 10, if deca, if isa lang siya mono, if dua di, if tatlo tri, if apat tetra, and 5 penta. That is the prefix that we use. Prefix meaning sa pinakauna. And ang niya din nga punta is added with the IDE. So when only one atom, the first element is present, the prefix mono is usually deleted, meaning wala na ginagamit si mono. And thus, COCO is carbon monoxide. Again, inabutang mo lang siya after the non-metallic element. Ang iya prefix, and you change it to IDE, ang iya nga suffix. So, carbon oxygen is now carbon monoxide. Ang carbon oxygen natin, or your carbon oxide, kung isa na siya is carbon monoxide. And CO2 natin, your CO2 is now called your carbon dioxide. Kay duwa kabilog ang iya nga oxygen. So when two vowels are adjacent, the A in the Greek prefix is usually dropped. So muna siya magpangalan, kids. Isang compounds composed of two elements. Kids, some other examples are shown in your table 2.7.6. You have SO2. If basahan to siya normally, it is your sulfur oxide. But kids, if we are following the proper naming of your nomenclatures of the elements, it is now known as sulfur dioxide. Magambalik ito SO3, it is sulfur trioxide, so on and so forth. But there are a few common names that you will encounter as you continue your study in chemistry. For example, although NO is often called nitric oxide, its proper name is of course nitrogen monoxide, kaya may isa lang sa oxygen. Similarly, N2O is known as nitrous oxide, even though our rules would specify dinitrogen monoxide, and H2O is usually just called water, but it's not dihydrogen monoxide. You should commit to memory the common names of the compounds that you encounter them. And next, we have your binary acids. Some compounds containing hydrogen are members of an important class of substances known as your acids. Binary acids naman, some compounds containing hydrogen are members of an important class of substances known as acids. The chemistry of these compounds is explored in more details in later chapters, but for now, it will suffice to note that many acids release hydrogen ions. Hydrogen positively charged when dissolved in water. To denote this distinct chemical property, a mixture with an acid is given a name derived from the compound's name. The compound is a binary acid comprised of hydrogen and one other non-metallic element. The word hydrogen is just changed to the prefix of hydro. Ang hydrogen, ginobra na natin when we are dealing with binary acids to hydro. The other non-metallic element name is modified by adding just the suffix of IC at the end of their name. And the word acid is then added as the second word in our second name. For example, when the gas hydrogen chloride is dissolved in water, the solution is just hydrochloric acid. Tanawan nyo ba, kids, ang hydrogen naging hydro, ang chloride naging clo, yung duwangan dahil ginislan ng IDE, ginislan dahil kids ang IC. So hydrochloric na siya. Then just add the second name acid. And that is how you name your binary acids. So these are examples naman, kids, on how you name your binary acids. These are the common names. First and foremost, you have hydrogen fluoride, derived from hydrogen and fluorine. Next, you have your hydrofluoric acid. Kaya ginubrata na siya nga liquid. Because HF in acid is hydrofluoric acid. Tanawan nyo, ang HCl nga hydrogen fluoride dapat naging hydrochloric acid. Ang hydrogen fluoride naging hydrofluoric acid. Our hydrogen bromide is now hydrobromic acid because ginubrata siya nga acid in liquid form. Next, we have oxyacids. When dealing with oxyacids na naman, kids, many compounds containing 3 or more elements, such as organic compounds or coordination compounds, are subject to specialized nomenclature rules that you will learn later. However, again, just as we have discussed binary acids briefly, we will discuss oxyacids man. Because we will discuss how the naming works and how important the compounds known as oxyacids bonded in such a way as to impart acidic properties to the compound. Typical oxyacids consist of hydrogen combined with a polyatomic oxygen-containing ion. To name oxyacids, how do we name, First and foremost, we have to omit hydrogen when we are dealing with oxyacid. Start with the root name of your anion. Magambal kita anion, these are your negatively charged nga atoms. Ginkakasta na ang hydrogen, ginsulat na lang gidya ang ion. Replace your ATE with IC, with ITE or OUS, and add acid to the last name. So, to check nyo bala ang HC2, H3O2, kids? Ang iya ni kids nga pagsulat is HC2, H3O2. But this is just now acetic acid. Why? Ang iya anion name is just acetate. This is an oxyacid, so we should omit hydrogen, and we should start with the root name of just the anion. Acetate. Acetate, ginislan kong ATE with IC, and add acid to the root name, to the second name. And that is how you name your oxyacids. For example, tanaman nyo naman ang hydrogen carbonate na ito. Your hydrogen is omitted. Hydrogen carbonate mong CO3. Ang carbonate mo ni kids, obrahon mo na lang nga carbonic. Omit the ATE. Pag omit mo sang ATE, butangan mo na lang ang carbon sang IC, carbonic, and add the name acid to the second name. And you will read it as carbonic acid. And that is how you name your oxyacids. So these are some examples of our common oxyacids. You have your nitric acid, derived from the anion name of nitrate from the formula HNO3. So on and so forth. Tanawan nyo na lang the kids. You have your sulfite, sulfurous acid. Your sulfate is sulfuric acid from H2SO4. And you have your phosphate. Your phosphate of H3PO4. May hydrogen kita, may phosphate kita. Tapos ang oxygen. But kids, magambal kita oxyacids. Kakson ta na ang oxygen. Phosphate siya, di ba? Pag phosphate niya, may oxygen siya. Kaya then hydrogen phosphate siya. Basta kakson niya, umit ta ang hydrogen. Ang islantang ATE sa IC, we now have phosphoric. Then just add the step number 5, which is add acid. And you will now have your phosphoric acid. So in summary, kids, your nomenclature. So chemists use nomenclature rules to clearly name compounds. Ionic and molecular compounds are named using somewhat different methods. Binary ionic compounds typically consist of a metal and a non-metal. The name of the metal is written first, followed by the name of the non-metal with its ending of IDE. For example, K2O is called potassium oxide if the metal can form ions with different charges. A Roman numeral parenthesis follows the name to specify its charges. FeCl2 is now known as your iron 2. FeCl3 is known as your iron 3. And this is when we are dealing with your isotopes and ionic compounds. Some compounds contain polyatomic ions. The names of the common polyatomics should be memorized. Molecular compounds naman, lain naman yato na pag-deal sini. When we are dealing with molecular compounds, it can form compounds with different ratios of their element. So prefixes are used to specify the number of atoms of each element in a molecule of the compound. Examples include SF6, sulfur hexafluoride, and 2-dinitrogen tetroxide. Again, ginaduangan today. Ang iyang prefix, sang di, tetro, mono, kung molecular compounds na naman siya. And acids are an important class of compounds containing hydrogen and having special nomenclatures. Kung oxyacids, ano to ganun kung oxyacids, we omit hydrogen. After ta omit sang hydrogen, butangan ta sang IC, ang puntasang anion and acid. When we are dealing naman with binary acids, so ano talang kids, we just write hydrogen, tapos i-shorten ang hydrogen into hydro. After na sulat mo anion name, butangan islan mong ATE, ITE into IC and add acid to the last name. And that is how your nomenclatures work. And again, ang ionic compounds nato naga-equal dapat ng ilang charge. But if you have molecular compounds, naga-share lang sila sa electrons and protons. And that will be all for our nomenclature discussion, kids. Thank you for your time. Have a good day and God bless.